Some practical applications of derivatives are looking for maximums and minimums. For example, when we have a function y equals negative x squared, usually we would find the maximum of this point using the vertex, by looking for the vertex. However, when we have more complicated functions, we cannot really do that. So what are local minimums and local maximums? Well, the definition of a local minimum is if the value of a point is less than the values of the points immediately around it. For example, if you look at the point here, the value of the left on the left and the value on the right of the point are both greater than that minimum point. Therefore, it is a local minimum. And notice that the tangent line, the slope at that point is 0. Same goes for local maximum, but vice versa. And lastly, inflection points are points where the shape of the graph changes from concave up to concave down, or vice versa. To find the local minimums and the maximums of this function, we have to look for the stationary points. Therefore, this would be 0 is equal to 3x squared plus 6x, which is equal to 3x times x plus 2. Then the stationary points are x equals 0 and x equals negative 2. Now you have to draw a number line. From 0 here to negative 2. Now substitute some values to test this into the derivative. This will return a positive number. If you put in negative 1, that will return a negative number. If you put in a really large negative number, then it will return a positive number. Because it goes from positive to negative, that means negative 2 is a local maximum. Because it goes from negative to positive slope, that means 0 is a local maximum. Max and min. That is how we find local minimums and maximums. And just as a final reminder, when f prime of x is equal to 0, the points that makes f prime of x is equal to 0 are stationary points. However, points that make f prime of x equal undefined are also stationary points. So for example, if f prime of x is equal to 1 over x, then and x equals 0 should also count as one of the stationary points. Lastly, let's go over how to look for inflection points. First, find the second derivative and set it equal to 0. Then, draw the number line using the points that you got from it, and if f of double prime changes, then it is an inflection point. Let's look at this example over here. We have x cubed, the second derivative is 6x. We set it equal to 0, then x is equal to 0. Draw a number line. Put some positive number back into the second derivative, then you will return with a positive number. Put a negative number, then you'll return with a negative number. Because the inflection changes, x equals 0 is inflection point.